Hello everyone and welcome back to my YouTube channel Eduimagica. In this video we will try to learn lung functions, and in this video we will basically focus on the lung volume and capacities, and we will try to understand that how these volume and capacities are useful in diagnosing the pathological state of a patient. So without delay or ado, let's begin. So we'll talk about the lung volume and capacities. Before getting into the topic directly, let us take a look at the respiratory tract anatomy. So the respiratory tract is basically divided into the upper and the lower respiratory tract. The upper respiratory tract basically includes the nostril, the nasal cavity, mouth, oral cavity, pharynx, and the larynx. Whereas the lower respiratory tract includes trachea and its division. And you can also include lungs over here because the division of the trachea basically descends into the lungs. Now let's take a look at the structure of the respiratory tract. As you all know that trachea is divided into the right and the left primary bronchus or the main bronchus at the point which is T5. This point is also known as the carina point. The point where the trachea divides is also known as the carina point. Okay, and this is T5. Now this trachea is guarded by a cartilage that is C-shaped cartilage, or it is also known as the incomplete cartilage. Why this cartilage is incomplete? Because this incomplete cartilage provides pathway to the esophagus on posterior side. So that is why it is incomplete on the posterior surface. Now we know that the trachea divides into the right and the left primary bronchus, or the right and the left main primary bronchus. Now these trachea basically continues into lungs and divides further. Now suppose this is lung. Now these lungs are basically guarded by ribs on the anterior surface and the lateral surface, and whereas on the posterior surface it is guarded by the spinal cord or the vertebrae and the ribs, and also by the scapula. Okay, now let me draw ribs. These ribs provide the protective function as well as the respiratory functions, because between these ribs there are intercostal muscles. These intercostal muscles helps in generating an pressure gradient it helps in generating a pressure gradient which further on helps in the breathing. Like it helps in taking the air inside and throwing that air out. Basically, it helps in inspiration and expiration. These are intercostal muscles. These are basically the external intercostals and the internal intercostals. And these ribs on the anterior surface, comes and joint at the sternum. Okay. Now, at this point where the trachea enters into the lungs, it further on divides into various or the different branches. Now it forms two zones over here. The branches of the trachea inside the lungs form two zones. They basically forms the conducting zone and the respiratory zone. The respiratory zone is that zone where the gaseous exchange basically takes place, and the conducting zone is that zone which basically, like we can say, that nourishes the air or removes the foreign particles, or like it helps in maintaining or making the air equivalent to the body temperature so that it doesn't damages the respiratory tract. Now suppose this is trachea which enters at the lungs. This is the lung. Now they further on divide. Now this trachea further on divide into bronchi. This is bronchus. Now they divide into bronchi. Now these bronchi further on divides into bronchioles. They further on divide into bronchioles. Now these bronchioles further on divides into the terminal bronchioles. Okay. Now these terminal bronchioles further on divides. They further on divide into the respiratory bronchioles. Now these respiratory bronchioles further on divide. They further on divide into alveolar ducts. And finally form the terminal end, that is the alveolar sac. Okay. Now till the terminal bronchiole, these branches which is above the terminal bronchioles, like we have the bronchi, bronchioles and terminal bronchioles, these come under conducting zone. Whereas the branches below the terminal bronchioles, that is the respiratory bronchioles, alveolar ducts and the alveolar sacs. These are the respiratory zones. Okay, and there is a muscular structure or muscular structure which is present below the lungs. Like suppose these are trachea, they divide into the right and left primary bronchus. And these are lungs, and below the lungs there is a muscular organ or the muscular structure that is known as diaphragm. This diaphragm basically helps in respiration by generating the pressure gradient as well. So this was some basic points about the anatomy of the respiratory tract. Now let's take a look at the lung volume and capacities. Like we all know that lungs allow us to inspire oxygen and remove or exhale the carbon dioxide. What it is basically the exchange of gases. Now suppose these lungs are basically performs the function for the inspiration and expiration, and we all know that the building block of lung, what the building block of lung is alveolus, where the gaseous exchange takes place. Now the calculation of the lung function or the volume and the capacities can be known after the displacement of the air volume during inspiration or expiration. Basically, if we talk about the lung function, for that we have the pulmonary function test. This pulmonary function test or the PFT basically involves two types of volume and capacities. We have the static and we have the dynamic. In today's video we will talk about the static. Okay, now suppose this is alveolar. So basically in this video I will talk about the lung volume using alveolus as an example, and this is just a concept for better understanding by learning the difference in the lung volume. And we will take a look at the lung volume of a typical adult male, because adult female have slightly lower values, but here the concept is the main thing. And if you will refer different books, you will find the different values for the volumes and capacities as well. So according to me, please refer a standard textbook. Like I personally use Ganong's physiology. Okay. Now the amount of air we breathe in and out, the amount of air we breathe in and out during a normal or the resting state, normal or the resting state is referred to as the tidal volume. What it is? It is referred to as the tidal volume. And the value of this tidal volume is around 500 ml. This is tidal volume. What is it? It is basically the amount of air we inspire and expire during a normal state or during resting state. Although we can take a deep breath in or the deep inspiration, which will lead to the increase in the volume in lungs. Over the tidal volume, we can also inspire deep. that will increase the volume inside the alveolus. What it will be? It will be inspiratory reserve volume. When we forcefully inspire more air other than the tidal volume, that basically forms the inspiratory reserve volume. It is around 2.5 to 3 liters. Okay. Now, like I said, I can inspire more other than the tidal volume. Same case, I can also expire more than the normal other than the tidal volume. That will be the expiratory reserve volume. What it will be? It will be expiratory reserve volume, and the value of this volume is around 1200 milliliter. And after the maximal or the maximum expiration, there is some air left inside the alveolus which cannot be exchanged. That air basically is the residual volume. And this is around 1100 to 1200 milliliter. Okay, this was about the four major or the four main respiratory volumes. But other than all this volumes, there is also some amount of air which is present in the respiratory tract, which does not take part in the exchange. Okay, there is some air which is left inside the respiratory tract which does not take part in the exchange. Suppose this is the respiratory tract and there is some air left which does not take part in the exchange. This air is basically known as the dead space. Its value is around 150 ml. This air basically helps the lungs or the respiratory tract from collapsing. This was all about the volume of the lung. Now let's learn more about the volume by representing it in a graph. Okay. Now here suppose we have x-axis and we have y-axis. This y-axis, this basically denotes the lung volume, okay, or the volume which is present in the adult male. We are talking about the adult male over here, so these all volumes will be according to the adult male. The y-axis denotes the lung volume, whereas the x-axis just denote the time. Okay, and we all know that the maximal or the total lung capacity is around 5.8 to 6 liters. And this value is not fixed because in different textbooks you will find the different standards for the lung volume and capacities. But here we will take it as 6 liter. Okay, so we will basically mark. Suppose this is 1000 ml. Here we have 2000 ml. Let us basically draw it using a ruler. Now let's assume it as 1000 ml for each block. Okay, this is 1000, this is 2000, this is 3000, this is 4, this is 5000, and this is 6000. That is the maximum. Now, as we have studied earlier that during a normal inspiration and expiration at a resting state, the amount of air we inspire and expire is the tidal volume. Okay, what is that? Normally what we inspire and expire is the tidal volume, and the value for that volume is around 500 ml. Okay, suppose this is the volume in which we inspire and expire during a normal state, that is around 500 ml. Now suppose if I inspire more than the normal, that is if I inspire more than the tidal volume, okay, in that condition it will be around 3000 ml other than the tidal volume. Okay, it will be around 3000 ml other than the tidal volume. Now suppose if I follow the tidal volume again, and if I inspire, or sorry, if I expire more than the normal or the maximum expiration, it will be around the 1200 ml. Okay, it will be around 1200 ml. So that is the expiratory reserve volume, and the amount of air which will be left after that will be the residual volume. So let's mark it over here. What is this volume that is denoted by blue? This is the tidal volume, and it is around 500 ml. Other than the tidal volume, the amount which are inspire maximum or the maximal inspiration after the tidal volume is the inspiratory reserve volume. Okay, it is around 2.5 to 3 liters. Now if I expire other than the tidal volume, that is the expiratory reserve volume, and its value is around 1200 milliliters, and the air which is left after the maximal expiration, that is the residual volume, and its value is around 1100 to 1200 milliliters. Now these volumes, when combined with each other in a random pattern or in a different patterns on a different combination, they form the certain capacities. Now what are these capacities? Suppose if I add up all these volumes, that is the respiratory volume, sorry, the residual volume, the expiratory reserve volume, the tidal volume, and the inspiratory reserve volume, when I add all these volumes, they will basically form a capacity known as the total lung capacities. So what is the total lung capacity? Total lung capacity is the amount of air which we can store maximum in our lung, that is around 5.8 to 6 liters, and that is RV, that is residual volume, plus expiratory reserve volume, plus tidal volume, plus inspiratory reserve volume. Now if I add up the inspiratory reserve volume and the tidal volume, the inspiratory reserve volume and the tidal volume, I will get the inspiratory capacity. Okay, now if I add up what I do, if I add up the expiratory reserve volume and the residual volume, I will get the functional residual capacity. Okay, and if I deduct or if I remove the residual volume from the total lung capacity, what I will get? I will get the vital lung capacity or the VLC. What is VLC? VLC is basically vital lung capacity. VLC is basically inspiratory reserve volume plus tidal volume plus expiratory reserve volume, or you can also say that vital lung capacity is equal to total lung capacity minus residual volume. Okay, so this was all about the lung volume and capacities. Now let us summarize and understand the volume and capacities in an easy manner. Okay, suppose this is a container. Just assume this container has lung. Okay, just assume this container has lung. Now we all know that the amount of air we inspire and expire at resting state is the tidal volume. So the amount of air the amount of air we inspire and expire in normal state is the tidal volume, and if I inspire more than the tidal volume, what it is? It is the inspiratory reserve volume, and if I expire, what I do? If I expire more than the normal, that will basically form the expiratory reserve volume, and the amount of air which is left after that is the residual volume. Okay, now if I add up inspiratory reserve volume and the tidal volume, I get the inspiratory capacity. Okay, if I add up the expiratory reserve volume and the residual volume, what I get? I get the functional residual capacity. If I add the inspiratory reserve volume, the tidal volume and the expiratory reserve volume, I get the vital lung capacity. And if I add up all these volumes, what I get? I get the total lung capacity. Total lung capacity. Okay, so this was a quick summary about the lung volume and capacities. Now, what are the role or what are the need to learn these volume and capacities? So these volume and capacities helps in diagnosing the pathological state of a patient. Why? In case of asthma, we can do spirometry. Spirometry is basically a test to assess the volume and the capacities of lung. Okay, so in case of asthma, these volumes are really useful in diagnosing the pathological state. In case of bronchitis, in case of COPD, in case of chronic respiratory disease, okay, so these are some uses for these volume and capacities. That's all for today. If you enjoyed this video and want to hear from me again, be sure to hit that subscribe button and don't forget to like, share and comment. Till the time being, नमस्ते, फिर मिलेंगे.